Here's a Razer E100. I took the scooter controller out of it and I figured that I could get most of the functionality that the little scooter controller provided by just simple wiring with two relays. Basically, I just wanted to be able to twist the throttle, get power to the rear motor. I don't care about the soft start. The under voltage protection would be nice, but that's not that big of a deal because I'm pretty good at watching the batteries. Um, I just threw this little diagram thing here together to kind of visualize it. It's kind of the first time I really ever drew something to assemble something like this, and I'm sure it's pretty non-standard way to draw something like that, but it worked for me. I've got the battery, and I'm doing 12 volts on this instead of 24. That way, half the speed for my son, since he is only 4 years old, we can boost it up to 24 volts in the future, no problem. But basically, I've got it currently to where it's going through a breaker, and then it's going to a master on-off switch, and then I have it going through a relay so that I can use the current throttle switch to trigger higher current switch for controlling the rear motor here. My plans are, and I'm using this little terminal block, and I plan on adding one more relay to what's currently here, and that is so when he presses the brake lever, I want it to kill power to the motor regardless of whether or not he is actually twisting the throttle. Now currently I do have the master switch on here, so anytime I do turn the throttle, it does turn with no variable speed because this was a simple on-off to begin with. And then if I switch it off just to make sure, no power. Done testing this out with my son riding it, and it worked really good, though the circuit breaker that is stock in here I'm going to have to bump up. It's like 7 amps, and I'm going to have to bump it to at least 15, which is actually the most I'll be bumping it to, considering the master switch is only rated for, I think, 16 amps. So I finished the modifications to this E100 Razer. I added the second relay in here. I wasn't able to use the 4-pin relay like I thought I was going to be able to do. I went ahead and just used another of the same type of relays, the 5-pin relay, and got it completely working the way I'd like. I've got it so that when I press the throttle here, I'm going to make sure my master switch is on. Get power there. But I also have it now with that second relay so that when I am holding down the throttle at the same time, and if I pull the lever, it will kill power to the rear motor. So that's what I wanted to do. And the last thing that I did, kind of last second thing, is I wired up the charger port so I don't have to try and repack all of this back in there. So that's it. Here's the Razer E100 using the charging port connector, 12 volts. Have it at, like I said, half speed for my son here. So I have the charging port going to a Power Wheels quick charger here. It's plugged into the wall, and that's how I will charge the scooter. That way I don't have to take off the deck and mess with all of the stuff that I packed tightly into the Razer. Okay, well, when I woke up this morning, I started to think about the way that I had wired the E100 scooter, and I realized that I did not need the second relay, that I could just run the connection between the brake and the throttle in series, and if either of those break connection, then it's going to kill power to the motor. So anytime that the brake lever is pulled, it would kill power to the motors regardless of whether or not the throttle was down. So came up with just an easy way to eliminate another relay, and then it got me to thinking, well, I would really like to prevent the throttle from, giving power to the motors when my charging port is connected. So I decided to redraw this so it would be easier to understand what was going on, and this way only uses one relay for the drive system and then one relay, a 4-pin starter kill relay for the killing power when the charging port is connected.